Hello everyone, welcome to Technogate. So today I'm going to discuss the divide and conquer. Okay, so the divide and conquer, how to works here. Okay, what is the time complexity in the divide and conquer? Okay, so there are two terms here, divide here and conquer here. Okay, so what is the meaning of divide and conquer here? So divide means divide the big problem into smaller size sub problems. First of all, okay, so divide means divide the big problem into smaller size sub problems. Okay, so first of all, divide the big problem into smaller size sub problems until one remain is left. Okay, now after division, recursively we divide, recursively concur. Concur means combining here. Concur means here combining. Concur means combine. Okay, so what is the meaning of concur here? Okay, so combine the sub problems. Okay, combine the sub problems how? Recursively, because the basic of divide and conquer is what? Recursion. Okay, recursively to get the original solution. Okay, to get the original solution, we combine the sub problems recursively. Means here divide from top to bottom here. Okay, and conquer from bottom to top here. So how it divides, like suppose that this is the array here. This is the array. Okay, so we divide in two parts here, n by 2 element here, n by 2 element here. Okay, for division, okay, two necessary things are what? Index here. So initial index p like that and q like that. Okay, so after division it will become like p2m starting index to midpoint here, and next one is a midpoint 1 to q here. Again we will divide here. Okay, so in this manner, like suppose that the unsorted array like that 5 3 2 6 here. Okay, this one. Okay, suppose there is one of the problem of divide and conquer here. So divide first of all. So divide here, like, so what will happen here? Here 5 3, here 2 6. Okay, after that again division. So divide this big problem into smaller size sub problems. So a problem become smaller when it's remain only one element here. So again it divide here. So here 5 here 3 here 2 here 6. Okay, so this is a smaller size sub problem here. This is the smaller size sub problem here. After the division, we combine the problem. Okay, we combine. So what are the applications you are using? According to that application, we combine this problem. Okay, suppose the merge short is there, then what will happen here? So 5 and 3. So this is shorted sub array here, shorted sub array here. So we combine them. Then what will happen here? 3 5. 3 5 here. Okay, and what will happen here? 2 6 here. Combine both of them. Okay, so 5 3 short. So this is unshorted array. This is unshorted array. After division becomes some smaller size problem, then this is a shorted array, this is shorted array. So how to merge these two shorted array? There is some applications, so we will discuss in the merge short. Okay, so 3 5 here, this is a 2 6 here. Again we combine both of them here. So what will happen? 2 3 5 and 6. Okay, this is shorted. So first of all division, then after combine. So division is what? Top to bottom here. Okay, and combine from bottom to top here. Okay, so this is a divide and conquer here. Okay, so let's see how to works here. So next one is control abstraction of divide and conquer. Control abstractions of divide and conquer here. So how it works here? Let's see. Okay, how it works here. So first of all, what will happen here? Whenever we divide the array, then two indexes are required here. So in the parameter passing, so what parameter will pass here? Starting index and last index. So divide and conquer, starting index and last index. P comma Q is starting index like this one. Here, this is P and Q. So divide this one. Okay. Suppose it like this is one index 1 here. This is 9 here. So divide this array. So 1 plus 9 by 2 here. So 10 by 2 it becomes 5. So here 1 to 5. Okay. 1 to 5 and next one is 6 to 9. Okay. This one. So starting point to mid and mid plus 1 to last one. Okay. This one. So let's see here. So P comma Q here. So if problem is small, okay, only one element is there. Suppose that there is only one element like a 10, and I am asked like that short this array. So it's already shorted. It's a small problem. So return only 10. Return only 10 here. So if small pq is there, then simply return solution p comma q. Okay, simply return same p comma q. So p is pointing here, q is pointing here, then simply return solutions to p comma q here. Okay, but if there are more than one element is there, then what is the else part here? Else part is what here? Divide this one. Okay, so divide this one here what? So take the midpoint here. So midpoint here. So divide p comma q. Divide p comma q here. Okay, this one. So here 1 to 5 here. So what is the midpoint here? 1 plus 9 starting index plus last index by 2, 5. So midpoint is what? 5. So after division every point, so recursively divide it. After every point we combine after that. Okay, so combine, what combine here? Starting to mid. Okay, so combine divide and conquer starting to mid here. Okay, starting to mid here, comma starting to, okay, so mid plus 1 to q here. Okay, so mid plus 1 to q here, this one, and return the whole solutions here. Okay, this is the divide and conquer works. So this is the way through which a divide and conquer works. This one, this problem is small, then return the solutions only. Okay, if a more than one elements, and then first of all divide it, and after that combine starting to mid and mid plus 1 to q here, and return the combined solution here. Clear? So this is a small problem. Okay, suppose that there are like a 3, 5, 7, 6, 2, 3 element is there, 2 and 4 is there. So more than one element, then divide this one. Okay, so how it divide is like that. So here 1, 2, 3, 4, 5, 6 here. So divide this problem here like that. So 1 plus 6, 7, 7 by 2 is 3. So first part is 1, 3, 5, 7 here, and here 6, 2, 4 here. So starting 1 to 3 here, okay, and here 4 to 6 here, this one. So start index to mid and mid plus 1 to 10. So every time we divide this one. Okay, so depending on the applications, so what do you want, like a merge sort, quick sort, find a max mean. So we will discuss in the upcoming lecture. Okay, so in this way we divide this one, and in this way we combine this one. Okay, so this is the working of divide and conquer. Okay, this is the working of divide and conquer. Now let's see what is the time complexity of divide and conquer. Okay, let's see. Okay, so how to decide the time complexity? Okay, how to decide the time complexity for the divide and conquer? Let's see here. Okay, it's a very important part here. Okay, so suppose that if n is small, okay, suppose that you are like, if there are n element here there, if n is small, if n is small, small means only one element is there. Okay, only one element. So suppose one element is given, then suppose 5 is given, and I want short this array, so only 5 is there. Okay, small problem, constant time, so it will take constant time, no recursion, nothing. Okay, if n is big, if n is big, if n is big, suppose that there are more than one elements are there, like 5, 3, 6, 2, 7 and 1. So divide this array, okay, divide this one. So n by 2 element here, n by 2 element here, every time in two parts here. So if n is big, then what will happen? Divide the array. Okay, divide the array in two parts. Okay, n by 2 element either, n by 2 element here. Okay, after that, every time division recursively, we combine the sub problem. We combine the sub problem recursively. Okay, so before division, okay, the function is by like a f1n here, unsorted array is like that. This is unsorted array, this is f1n. Divide two part here, n by 2 element, n by 2 element. So these n by 2 element, like a 5, 3, 6. So these n by 2 element time taking t n by 2 time, t n by 2 time here. Okay, so it will take t n by 2 time to sort the array. Again, this second half will take t n by 2 time to sort the second half of the array and combine. After combining, suppose, so after division like that 2, 7, 1, and at the last it will become what? Combine function is what here? Like 1, 2, 3, 5, 6, 7. So function changes here. Here unsorted array, this is sorted array. Function changes here. Okay, so this is function. So because of differentiation is unsorted array before division, and after division combining, this becomes sorted array like that. Okay, so here n element is divided into n by 2, n by 2. So these n by 2 element taking t n by 2 time to sort the recursively, and here second half like taking t n by 2 time, and after that this one. So what is the time complexity here? Okay, what is the time complexity here? So let's see here. Tn is the time complexity to sort an element here. So if problem is small, okay, if n is small, how much time it will take? Constant. How much time it will take? Constant here. Okay, so if n is small, okay, if n is small, it will take constant time here. Okay, but if n is more than 1, then what will happen? The function n, f1n plus first half taking tn by 2 time, okay, plus second half like taking tn by 2 time, and after this second function, if n is big, if n is big here, okay, if n is big, okay. So what will happen here? This is a tn by 2 plus tn by 2. What will happen? 2tn by 2. So 2tn by 2 plus fn. So always this function divide and conquer. Always this part divide and conquer. Suppose that like that this is 2tn by 2 plus n here. Okay, so this n element here, it may be n square also, it may be exponential also, it may be n cube also. So it may anything also here. So n elements divide here, n square element divide here, exponential divide here, n cube here. So every time we divide this part and conquer this part here. So here, what is the meaning of 2? So there are n elements are divided into two parts, 1 and 2. This is two part here, and size of each part is what? This one, n by 2, n by 2. So this is a t n by b plus divide and conquer. So a is what? A number. In how many numbers we divide? In two numbers. Okay, in two part we divide. So it's a part, and this is what here? Size. Size of each part. Size of each part. So there are n elements are divided into two part. 1 2, and size of each part is n by 2 n by 2. Okay, this one here. So in this way the divide and conquer works here. In this way divide and conquer works here. Okay, n by 2 elements here. Okay, so we can divide in also 3 part also. Suppose that I am writing here okay, let's see here 3t n by 2 plus n square. So what is the meaning of this one? Meaning of this one is n square element is divided into 3 parts. Okay, size of each part is n by 2 here, n by 2 here, n by 2 here. Okay, so we will discuss in the upcoming lecture more of the how to solve the recurrence relation for this one, how to solve the applications of here divide and conquer here. So every time we divide this part only. Okay, if we solve the problem through divide and conquer. Okay, so let's see what are the applications of divide and conquer. So next one is what? Applications of divide and conquer. Applications of divide and conquer. Okay, so let's see this one. So what are the applications covered through the divide and conquer here? So first very important application is find max and maximum and minimum element in the given array. In the given array. Okay, so what is the maximum and minimum element in the given array? Okay, so before applying the divide and conquer approach, we will solve the finding max and minimum without a divide and conquer, so that we can differentiate which one is the best. We can conclude with a divide and conquer is the best or without a divide and conquer is best to find max and mean in the given array. So we will compare both of the things without the divide and conquer and with the divide and conquer, so that we can conclude all the things here. What is the space required? Because if we apply divide and conquer, then definitely recursion will exist. And recursion means space complexity will exist here. Stack complexity will exist here. Some of the part from stack will be used. Okay, if we apply the divide and conquer. And without divide and conquer, there is no space, no stack is used. So we will see both of them, divide and conquer and without a divide and conquer. Okay, next one is, next important application is power of an element. Power of an element. How to find the power of an element here? Again we apply same thing without a divide and conquer and with a divide and conquer, and again we differentiate without a divide and conquer power of an element is best, or with a divide and conquer power of an element is best. Which one is the best here? Okay, let's see here. Third very important application is a binary search. Okay, binary search here. So binary search is a very important applications. Many of the problems definitely will come through the binary search here. So there are two type of searching here, linear search and binary search. So we will discuss linear search as well as binary search. So binary search is applicable on the shorted array. Okay, what are the worst case time complexity, what is the best case time complexity, what is the average case time complexity. So we will discuss all total scenario about binary search in the application part here. Next, fourth very important application is merge sort. Very important application is a merge sort here. Okay, so in merge sort we divide the array recursively and we combine, means merging the array. So here merge procedure is very important. And what is the best case time complexity, what is the worst case time complexity, what is the average case time complexity. So we will discuss all about in the merge sort topic. Okay, it's a very important topic. Next one is again very important, is the quick sort. So definitely either from merge sort or quick sort, definitely one of the problem will come definitely. Okay. So here there are what is the worst case, what is the best case. So these two cases are very important, best case and average case here. So we will discuss both of them in the application part. Next one is selection procedure. Selection procedure means we want to find the second largest element, third minimum element, fourth largest, fourth maximum, kth maximum, kth minimum. So if you want to find kth maximum and kth minimum element, we want a selection procedure and it based on the divide and conquer. Okay. Next one is Stratian matrix multiplication. Stratian matrix multiplication. So this is seventh application here. Okay. So these three are very important here. These three are very important. So we will discuss about the good manner and deep manner. What is the binary search? What is the merge sort? What is the quick sort? All about complexity. All about the gate problem also here. How, which type of problem they ask in the gate examination. So we will discuss these 7 problems in the next upcoming lecture. So first we start from the find the maximum and minimum element in the given array. So these 7 applications are very important and divide and conquer is a very important topic here. So definitely there are 3 to 4 marks problem. There are 3 to 4 marks problem will definitely come from the divide and conquer topic. So we will discuss all of the gate problems in the divide and conquer. Okay, all of the problems of the greedy method also, all of the problems of the dynamic programming also. So we will discuss every single problem of the gate. Okay. Okay, thank you everyone.